Hi, this is Mr. Reg again, and we're graphing inverse functions. I'm going to show you the easiest way how to graph an inverse function, which is basically making a table of values for my original function. That's my original function. Okay, I make a table of values and then I switch the x and the y values. Alright, so my outcome is basically I want to graph my function itself. I want to graph the inverse function, which should be something around there if that's the case, and I want to graph the line of symmetry, which is y equals x. So I'm going to graph my function, the line of symmetry, and your inverse function. Okay, I always ask for those three lines whenever I'm graphing inverse functions. So the first thing I need to do is we're going to graph using the table of values to make our life easier. Table of values, y, let me do this on the other side so we have space underneath. So I'm going to make a table of values, okay? As general, I like to use -2, -1, 0, 1, and 2. Okay, as many points as we can so we can see, detailed line. Now we're going to do with those x values is I'm going to plug them into my function. Alright, again, remember, f of x is the same as having y. Okay, just in case. If you remember, the process to find the inverse of the function was changing the x and the y. What's y is going to turn into x, and what's x turns into y. So that's the reason, in a minute, when I find my table values for my function, you're going to find out that I'm going to flip what's x is going to be y, and what's y is going to be x. Okay, you'll see that in a minute. So let's start from the beginning. We're making a table of values for my function. And my function is f of x equals 2x minus 2. That's my function. I replace the f of x by y, so you get confused with notation over here. Okay? Now, when x is -2, there's going to be 2 times -2. That's -4 minus 2 is going to give you -6. Yep, -6. When the x is -1, then it's going to be -1 times 2, -2 minus 2, -4. When the x is 0, this turns into 0, and your y is going to be -2. When it's 1, then it's 2 times 1 is 2, minus 2, 0. When that's 2, it's going to be 2 times 2 is 4, minus 2 is 2. So this is my table of values for my function. That's for my function. Now, I said whenever we're doing inverse functions, interchange. What's y turns into x, and what's x turns into y. Basically, I'm flipping the x and the y. Alright, their domain and range. So now, this table of values here on the red side, that's going to be for your inverse function. Okay, that's going to be the table of values for your inverse function. What's x here in my function, it will be y on my inverse. What's y on the function, it will be x on my inverse. So I'm going to write those values. -6, -4, -2, 0, and 2. Alright? Those are my function and my inverse function. So I'm going to go and I'm going to graph that. So let me use that those values in the other one. So -1. I need to clear this out. Clear the page. Okay. So my function, my first is 2x minus 2. 2x minus 2. 2x minus 2. Your table values was -2, 1, 0, 1, 2, and if I don't remember, let me see, and then you have negative 6, negative 6, negative 4, negative 2, 0, and 2. Okay, I'm going to graph my function first of all. So, when x is negative 2, your y is negative 6. 1, 2, 3, 4, 5, 6. Negative 1, negative 4. Negative 1, negative 4. 0, negative 2. 1, 0. 2, 2. So your line, let me try to use this as a ruler. Oh my god, I can't. Your line is gonna be, sorry, I went through the other point. That's gonna be your line. Okay, let me do it again. Actually, let me try a better job. There we go. I guess that's a little bit better. All right. So that's your function. That's your function. Okay. Now, your inverse function. Let's do it with red. Again, your inverse function is going to be flipped. It's going to be x and y. Okay? So all these values that I have on x, they're going to be on y. And all these values that I have on y, they're going to be on x. Negative 6, negative 4, negative 2, 0, and 2. This will be for your inverse function. I just need to plug those values. So let's do with red, I guess. Negative 6, negative 2. 3, 4, 5, 6 is going to be negative 2. Negative 4, negative 1. Negative 4, negative 1. That's the next point. Negative 2, 0. Negative 2, 0. 0, 1, 0, 1. 2, 2. And they share that point. Let me draw my line. And that's my inverse. So the red is the inverse, the blue is your function. Now, these lines, they have symmetry among the line, and I'm going to do with green, y equals x. Okay? They have symmetry among the line. I'm going to make a table values for that one. The table values, those values for this line is basically all, let me do it here real quick. So table values for that. If the x is negative 2, the y is negative 2. If the x is negative 1, the y will be negative 1. It doesn't matter what value I replace here, it's going to be the same as the y, basically. So no matter what value you replace, the y is going to be the same. Okay? So I got negative 2, negative 2, negative 1, negative 1, 0, 0. If I continue here underneath, it will be 1, 1, 2, 2. So negative 2 on x, negative 2 on y, negative 1, negative 1, 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7. All those points belong to the same line. Okay, which is a 45-degree line. And that line is y equals x, which is your line of symmetry. That line is called line of symmetry in this case. If you notice, this point is symmetric to that one. This should be to that one. That to that one. Look at this, is one away from that, okay? So this green line is a line of symmetry, okay? So those are the three lines that I always ask for whenever you're graphing. Your function, flip the x and the y, and you get the values for the inverse function. You plot those values, and then you do your line of symmetry. Always those three, okay? So, okay, take care. I don't know if I'm going to do another one. Let's do another one, just in case, real quick. Okay, let's do this one. Half of x plus 1. If you remember, first thing I need to do is a table of values. Negative 1, 0, 1, and 2. Okay, plug it in. Negative 2, that's negative 1, that's 0. negative 1, that is negative 1/2, so that's going to give you half. 0 is going to give you 1, 1 is going to give you 1 and 1/2, 2 is going to give you 2. Okay, so let me plot those values. Let's plot it with red. Negative 2, 0, negative 2 and x, 0 and y, negative 1, half, negative 1, around there, actually lower than that, 0, 1, 1, 1.5, 2, 2, and that's my line. It's a really slanted line. Okay, I flip those values for my inverse. So let's do my inverse over here in the bottom with blue. My inverse values are going to be flipped, x, y. So I'm going to have negative 2, negative 1, 0, 1, 2. And what's y values is going to turn into x, half, 1, 1.5, and 2. You see, I flipped these values. The y values are going to be your x values. Your x values will be your y values. That's all what you do. Flip those two, plot and graph. I just graph my function, which I use, I use the red, so that's my red right now. Now I'm using blue for the inverse function, so let's graph that. 0, negative 2, 0, I'm using blue, 0, negative 2, 1/2, negative 1, 1/2, negative 1, that's not 1/2, 1/2, negative 1, 1, 0, 1, 0, 1.5, 1, 1.5, 1, 2, 2, and here we go, they intersect again. They don't necessarily have to intersect, so this is a coincidence that they're intersecting. Okay, this is a coincidence that they're intersecting both. They don't have to intersect. Now, this is my inverse function, and this is your function. Now I need to find my line y equals x. From previous, I don't have it, erase it. Previous, the values are the same. 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, negative 1, negative 1, negative 2, negative 2, negative 3, negative 3 is a diagonal line. Okay, it's a diagonal line, and that's your line of symmetry. Okay, those are the 3 lines that I want. Please, always your function, your inverse, and your line of symmetry, so you can see that on the graphs. Okay, study please. Take care. Have a good one.